The Diary of Dr. X, episode 26. Why we need alternative energy, or the problems with fossil fuels. This would be the third of my lecture series on products as pollution. We spoke about the persistent organic pollutants produced by the chemical industry and nutrient pollution earlier. This leaves us with the toxic pollution associated with fossil fuels and the nuclear industry, which, taken together, provide the vast majority of the energy we consume. So, the vast majority of our energy currently comes from fossil fuels. Even more so than nuclear power, which is fairly minor in comparison. And the fossil fuels include coal, oil, and natural gas, and I will primarily focus upon them. So why do we need an alternative energy source? The answer is simple. And it comes in two parts, based upon the ecology's two principal criteria for distinguishing between eco-friendly and ecologically destructive technologies. First, none of our major energy sources are sustainable. And second, all of our major energy sources pollute the environment. So there you go, sustainability and toxicity once again. In terms of the fossil fuels themselves, coal is by far the dirtiest, followed closely by petroleum or oil, and a bit more on the cleaner side by natural gas. In fact, a switch to natural gas for transportation fuels would be vastly preferable to oil over the short term, but it is not a long-term solution. The first problem with fossil fuels is as I mentioned, is that they are not a sustainable source of energy. Fossil fuels are essentially ancient organic material which has been transformed by various geological processes into combustible form. Thus, they truly are fossils of ancient organic life. The problem is that all of them exist in limited quantities, which are used up as they are consumed, the very opposite of a sustainable resource. While coal remains relatively abundant, it is by far the dirtiest of the three. It is only slightly cleaner than burning wood, in fact. So you guys, and there's plenty of them out there, who are recommending wood as an alternative, should give your heads a shake, because coal is actually an improvement over wood. Natural gas, as mentioned, is also available in fairly large quantities and much cleaner, but it is only a short-term solution at best to our energy needs. Oil is probably already past its peak availability, if you've been reading the literature, and quickly diminishing with increases in demand as China, India, and other former third-world countries modernize their economies. Much more important than the fact that fossil fuels are unsustainable, however, is the fact that they are incredibly destructive ecologically. Let me describe that for you. I assume you're all aware of this destructive potential of large oil spills such as the Exxon Valdez disaster a decade or two ago, or the British petroleum oil platform disaster in the Gulf of Mexico more recently, just a year or two ago. Well, less well known than these massive scale disasters that attract the world's attention, and much more insidious, is the fact that groundwater is being polluted by petroleum as well, as Sampat points out in her 2000 article, Groundwater Shock, from the World Watch Institute. This is due to our habit of building underground storage tanks for gasoline at fueling stations. When those tanks develop a slow leak, it is often undetected for a long period of time. And even when it is detected, it is often not fixed due to the expense. The slow leak of petrochemicals ends up in the underground water reservoirs or aquifers. These are the sources upon which wells draw for drinking water. Many aquifers throughout North America and Europe are already polluted, and depending on the recharge rate or the time it takes to flush them with new water naturally, could remain so for centuries. There are a couple of other negative effects which are also less well known in the media, but still quite important. The first is particulate pollution. A recent study of air quality in several major cities in North America concluded that fossil fuel pollution outdoors is comparable to secondhand smoke indoors as a potential cause of lung cancer, back when we used to be able to smoke indoors, since they are essentially the same thing. Coal is particularly high in particulates, and prolonged exposure to particulate pollution can cause a variety of health effects, including respiratory and cardiovascular problems such as asthma, emphysema, bronchitis, lung cancer, of course, and heart disease. Particularly bad coal smogs, which emphasize the importance of particulate pollution, killed 2,200 Londoners in England in 1880, for example, and another 4,000 as late as 1952. The world's 10 most polluted cities, mostly in China, are all heavy coal users as well. Globally, it is estimated that particulates and other pollutants from coal and other fossil fuels continue to cause about 500,000 premature deaths and millions of respiratory illnesses per year. Mining coal is also not a healthy profession, commonly leading to pneumoconiosis, there's a tough one, or black lung from constant inhalation of coal dust. Fossil fuels also contribute to another problem, namely nitrogen or nutrient pollution, which I mentioned before, from the breakdown of nitrogen oxides, which are produced by the combustion process itself, all combustion. Even in internal combustion engines, burning hydrogen, which we will talk about again later, produce some nitrogen oxide, so in much, much lower quantities. Along with artificial fertilizers and concentrated organic sewage, the breakdown of nitrogen oxides can contribute to algal blooms, blue baby syndrome, which kills human infants, and eutrophication events in bodies of water, as I talked about in a previous episode. Burning fossil fuels also contributes to a further problem, namely the formation of ground-level ozone or smog. Ozone is O3, 3 oxygen molecules. So NO3, nitrogen oxide with 3 oxygen molecules mentioned above, breaks down into nitrogen and ozone, with the latter being bad for the health of humans and other animals. Again, you may have heard of ozone depletion being a bad thing, even in CCP media. Well, it turns out that ozone is good for us in the upper atmosphere or stratosphere, where it protects us from harmful ultraviolet radiation from the sun. But in the lower atmosphere or troposphere, ozone actually becomes a pollutant. Depends on where it is in the biosphere, you see. That leaves us with the big two when it comes to fossil fuels' negative effects on the biosphere, namely global warming and acid rain. Taken together, and considering the billions of tons of these chemicals being added to the world on an annual basis, they could very realistically render the biosphere, which sustains human life, uninhabitable within the next few decades, if not, in fact, tomorrow morning. So let's start with global warming, or climate change. Burning fossil fuels, which are all carbon-based organic molecules, contributes to global warming, or the greenhouse effect, due to the release of massive amounts of CO2, carbon dioxide. Greenhouse gases are gases which cause the atmosphere to retain more heat when they are present in larger amounts, such as CO2. They act like the glass in a greenhouse does, hence the name, which reflects some of the sunlight that enters a building back inside. causing the structure to retain heat, but on a global level. That's called passive solar heat if you're building a building, but on the biospheric perspective, well, not so good. The most important greenhouse gas, as mentioned, is carbon dioxide itself, along with methane and a few others, which is released by the combustion of all of the fossil fuels. It is also released by the destruction of tropical and other forests globally, where the carbon released combines with atmospheric oxygen to form CO2. In fact, forests are carbon sinks. You see, plants take in CO2 out of the atmosphere and use it to build their cells, giving off oxygen with ourselves and other animals breathe. Awful nice of them, as I think I've mentioned. Thus, clearing forests is actually a double whammy, which contributes to global warming as well, since it not only releases stored carbon, as the burning of fossil fuel does, and at a greater rate, but also reduces the biosphere's ability to process carbon dioxide at the same time. Other greenhouse gases include methane, as I mentioned, water vapor, especially in the upper atmosphere. In the lower atmosphere, it's normal. And CFCs, or chlorofluorocarbons, which are also involved in ozone depletion, which is a separate problem. In combination, burning fossil fuels and deforestation both promote an increase in the carbon dioxide content of the atmosphere above the range required in order to maintain global average temperatures within their optimum range. And we've talked about optimum and its importance in organic systems before. What is happening is that we're releasing carbon dioxide much faster than the biosphere can naturally process it, since fossil fuels are stored organic energy, or carbon, which have been buried for millions of years, remains of prehistoric life. We're bringing all that to the surface within only a couple centuries and now decades. The chemistry of the problem is really very basic and simple. Releasing all that carbon will warm the biosphere. No doubt about that. It's obvious, basic chemistry. The consequences are where we get into all the arguments in the media of what's going to happen, how long it's going to take. On that side, of course, things are very highly unpredictable. And why? Because the biosphere is a complex organic system, you see, just like you and me. You can press the same button or give the same stimulus over and over, and one day it may do something completely different, including flipping into a completely different state in a very short time. In class, I've also often used the example of how complex systems can react by referring to the example of two people who meet every day before they come into my lecture. And every day the first person will say, "Hi there, beautiful day out, isn't it?" And the other will say, "Yeah, it sure is." But one day, they both come into class, and the first person says, "Hi, beautiful day out, isn't it?" And the other one breaks down in tears. Why? Well, the first person asks, and it turns out their parents just died in a car accident. Terribly sad thing, right? Completely different reaction. Same stimulus, completely different response. Why? Because the context has changed. It's reached a flipping point. The same is true of all complex systems, including the biosphere. We can keep adding carbon and adding carbon and adding carbon, and nothing much will happen. And one day, bingo, wake up in the morning and things are completely different. So, as an illustration of the extent of the problem of global warming, coral bleaching, or die-offs, are already becoming more and more common on a global basis throughout the world. Coral reefs are the most ecologically diverse marine habitats and the basis of the food chain in many areas. They also have a very small tolerance for increases in temperature, which causes them to die back or bleach. They turn white. These episodes are increasing in recent years. This is a major concern because, once again, they are the basis of ecosystems in many areas. And if you take out the base of an ecosystem, the top dies because everything above that is dependent on the bottom. Equally frightening is the problem of acid rain. Acid rain is caused by the release of various compounds which cause changes in the pH, or acidity or base levels, of soils and water bodies. These include sulfur dioxide, or SO2, from the burning of coal in particular, as well as nitrogen oxides, mentioned previously, from the burning of fossil fuels and all other combustion. Acid rain damages vegetation, soils, crops, rivers, and lakes. The first event to bring the problem to public attention in the media were major fish kills in Norway in polluted bodies of water back in the 1970s, I believe. Acid rain has also led to the decline of forests throughout much of Europe, as well as the northeastern United States and eastern Canada, and China and India can expect similar problems as they industrialize. Since the 1960s, a number of clean air agreements have been enacted, which focused mostly upon reducing sulfur emissions rather than eliminating coal use, of course, and did nothing to regulate nitrogen oxide emissions. Thus, even with reduced sulfur emissions, the problem persists. Forests continue to decline, and many lakes and rivers suffering from acid stress will take years to recover, assuming that the problem is someday resolved, because acid rain can literally kill lakes and all life in them. And it goes without saying that lakes and rivers drain into the oceans. Surprise, surprise! So, the acidity of the oceans themselves are already on the rise. Why is this problematic? Because if acidity levels rise far enough in the oceans, it could kill off the zooplankton and the phytoplankton. What are those? Well, they form the basis of the food chain for the entire marine ecosystem. The zooplankton are microscopic animal life. The whales eat them, many species anyways. And the phytoplankton, well, what do? They provide about 40% of the world's oxygen. So what does that imply? Well, if the phytoplankton dies, so does the marine ecosystem, which is dependent upon it, and so do we. Especially since we are also destroying the forest, which provides most of the rest of our oxygen, along with the rest of plant life on the planet. So, fossil fuel use is basically a massive chemistry experiment. Just as the production of POPs or persistent organic pollutants is, and just as nutrient pollution is. They are all collectively changing the chemistry of the ecological systems we rely on for our survival. And those promoting and selling them couldn't care less. More on that in a future episode. Oh, and then, of course, there is nuclear power, the remaining conventional source of energy. It is even touted by some as a solution to global warming because it creates no greenhouse emissions nor acid rain. Both are true, of course. It does, however, create toxic nuclear waste which is deadly to all life for tens of thousands of years. In fact, if the ancient Egyptians had built nuclear reactors 10,000 years ago, those wastes would still be 95% as toxic today as they were when they were first stored somewhere safe by the ancient Egyptians. I'm sure any sane person would reason that using them to fill in the gap and keep our unsustainable society running for another few decades is not worth the cost to future generations, particularly when you keep in mind that fissionable materials are likely to run out even faster than fossil fuels if utilized more rapidly. Nuclear power is not only massively anti-ecological, even compared to fossil fuels, but also an even less sustainable option when it comes to dealing with our energy needs and how long it will last. So on both the sustainability front and the ecological destructiveness front, the two ecological criteria used to judge the ecological appropriateness of technologies, fossil fuels, and nuclear even worse, fare incredibly badly. They are not only being rapidly depleted, but are threatening the biosphere in the process of being used. And the sooner we find sustainable, emission-free replacements for them, the better off both humanity and the planet shall be. Assuming it isn't already too late, as it very well might already be.